Hi everyone, welcome to this video. And right now you're probably thinking, what on earth is this? Well, this is the solar controller, the solar power system controller if you like. And as quite a lot of you know, I started doing this a few years ago, but it's been off and on and whatever. But the past few weeks I've been spending some time on it and improving it again. I think now there have been a couple of different versions of it, and this is the very latest version, or the 2019 version. And to be honest, I'm getting to the end of it, it looks. Anyway, so this is the latest one, and I'm going to show you all the different bits and pieces and the ins and outs of how it works. To start with though, I thought I'd just tell you exactly what it is, for those who haven't been following the videos. So what this is that I've got a small off-grid solar panel system, and I want to be able to manipulate it basically with automation systems. So I want to be able to turn the inverters on and off. I want to be able to switch between mains and solar power, and I want it to just intelligently decide. And basically, I want it to log every bit of data that it can to a server so that I can browse on the web or on the website and just understand how things work and what data has been taken and what's going on with it. So the reason why this whole issue of relays is important is because, of course, we solely have to look after your batteries. I mean, it's an off-grid system. I have 24 volt batteries, well actually 12 volt batteries in parallel, and well, series parallel. And you shouldn't be running solar if the voltage of the batteries is low, because of course you'll damage the batteries. At the same time, you don't want to not be using solar when you could be using solar. So maybe it's very light outside, maybe the batteries are fully charged, maybe the batteries are not fully charged but you are in for a day of sunlight, or maybe the batteries are fully charged but you think they're going to be drained and therefore you won't be able to charge them back. So anyway, that's the idea of this system. It's got to decide between solar and mains, with of course the ultimate idea of dramatically reducing an electric bill. So that's the idea of it. Anyway, I'm going to go through the parts now and explain what it does. Essentially, this thing is a data collection thing, or a logging thing, as well as a couple of other things, but that's one of its main ideas. So that's one of the main ideas behind it. Anyway, let's start here, because this is pretty much where the majority of it starts. So we've got a solar charge controller, which if I remember rightly is called BN4215 or something like that, 4230 or something, I can't remember. But it's a thing that you plug or connect the solar panels to, and it decides when it can charge your batteries, and it's an MPPT thing which charges the batteries properly. I mean, that's basically the idea of it. But this device has an Ethernet port, or an RJ45 port, and I figured out how to extract data from this port using Modbus, and that's what I do. So RS485 Modbus. So I managed to work out how to talk to it, if you like. So I do talk to it using this module here. So this module connects to the solar charge controller, and this basically converts data from between the Arduino and it itself. So this asks for data, the solar charge controller sends it to this via this, and that's how it works. So all communication between the two goes through this here. So basically that's how I get data, or pull data, every second from the charge controller. And then with the data received from this Arduino here, I send it to the ESP32. So you might be thinking, well, why do you need that? Why don't you just use the ESP32? Well, the reason is because the ESP32, for whatever reason, just doesn't work with Modbus. I mean, you can get it to work sometimes, but it's not reliable, and basically it's just easier to use this, although it's a bit silly because it just could be connected to that, but it just doesn't work easily, so I didn't do it. So yeah, this pulls the data from the charge controller and sends it back to here via serial. And then that's the main source of data for the ESP32. The ESP32 is the main brain, if you like. It controls everything. So that's that. Now there's also an LED there which you can see, and that's when it receives data. When it receives data, it blinks. So, next thing, you can see a load of LEDs here, and they're basically status LEDs from the ESP32 itself. So if you know, if the inverter's on, it does one. If you know, if this one's here, this one here is the source. So hang on a minute, let me just power this up. Where's the switch? Let's power this up. In a minute it'll be ready. So yeah, these all indicate something or other. The next thing is that I've got the React module here, which is a transceiver. I'll just zoom in again. The React module is a transceiver, and that gets connected to my monitor or controller. And the monitor or controller I did a video for yesterday, so you'll be able to see that if you just look at my channel for yesterday. And basically that little thing waits for requests, and then it replies to the request. So the monitor asks for some data and it sends it off, and it's connected directly to the ESP32, and that's what controls it. So it can also accept commands and stuff as well to change its decisions. Maybe I should just show you that now. I think I'll try to. Just one second. Okay, so I'll just bring the controller or the monitor over, and you can see it says AI and there's an LED on here. So I'm going to try and turn the AI off. So this is wireless, so I'll turn it off, and you can see the LEDs out now. And if I go to source, maybe I can change that to none, and you can see a red LED. I'll change it to mains. Goes off. If I change it to solar, it should be a different colour maybe. No, maybe it's broken. But inverter, will turn that on, and you can see the bottom LED glows, and we'll turn it back off. Turns off, and AI will turn that back on. So you can get a rough idea of how it works. So anyway, let's carry on. They also have this little keypad here which does various things like turn AI on and off, and various other things, but again that doesn't work properly at the moment. The coding and all that's right, but the problem is that this board here, I damaged the board, so that's why this doesn't work properly. But I'll sort that out soon, because these boards need redoing. I've only actually done the main modules rather than the little auxiliary things, which don't matter too much. But yeah, let's carry on. So the ESP32 is there, and basically it interacts with all these other modules and stuff. So here we've got the input from the Modbus polling device, which is a Pro Mini. I've already explained that. There's a buzzer, obviously you know what the buzzer does. Then there are various connections here which go to contactors and relays. And there's actually a relay for the inverter, so if I do that thing there to turn the inverter on one of these, it actually sends a signal to a relay to turn it on or turn it off, and that's to turn the inverter on and off, of course. And also there are the contactors. Now the contactors have two transistors, and the transistors switch between different states, of course, in order to turn one contactor on and the other one off, and vice versa. So there are two transistors or MOSFETs, and they're controlled by these pins here, and there's ground, of course. And then you can see here there are two wires. These are I2C wires, and they go to some other little sensors which are here. So what have we got here? We've got a light intensity sensor, which of course is designed to measure the sun, the strength of light from the sun. It's supposed to go outside in a box, but the the box got damaged, and I guess I lost interest at the time and I didn't look after it properly. But that's a new sensor, and as you can see, it's wired up there. I2C. Yeah, that needs to go in a transparent box on the roof next to the solar panels. The idea is, of course, to see how much, or see the intensity of light that falls upon the solar panels, so that I can do different calculations based on that. Just for intelligence gathering, really. So we've also got these two are power and ground. We've also got this module here, which is a 16-bit ADC and PGA. ADC is analog to digital converter, and PGA is I can't remember exactly, gain amplifier, programmable gain amplifier, I think. And the idea of that is to be able to read the amount of current which flows from the solar panel system in order to drain the battery, the amount of current that is currently draining the battery, so that I can log it. And of course that gets sent via I2C also to the ESP32. I think I'll just zoom in a bit more here so you can have a better look. So yeah, that's configured by the software. I get a current shunt and I plug in the two parts of the current shunt to there, and it amplifies it and whatever and sends a signal back. And the other thing I've got is an RTC. Now this RTC doesn't work properly. It seems to forget the date. When it's off, it seems to just not work. Now I don't know exactly what's up with that, but it's DS3231. And of course the idea is to send the date and time to the ESP32. And that's pretty much everything as far as the hardware is concerned. And of course I've got this antenna here because the ESP32 connects to my router, which in turn is supposed to connect to my server. So that's everything. Now I'll just show you the date and time again. Let's see. I did set this a few days ago, and it's already out. It's definitely not 6 o'clock in the morning. So 7th of February, 21:42. So it's way off. No, I don't know why, but whatever. But I mean, I've actually set it a few times, and I've changed the cell on the RTC, but it just doesn't work. So I'll have to sort that out another time. Maybe I'll buy another one or something. I don't know. Anyway, so this thing it needs a little bit of a redesign. These boards need a little bit of a redesign. And you know where where we get these wires here, so this one to this one, it would be better if I use one of these, I think. But ultimately it'd be better if this was just one board. But I'll need to sort that out anyway. I'll need to solder the backs of these tracks because some of them have got cracked and whatever as it's been working. And there are also some other little bits which I've not shown you, which of course are stuck in the solar shed. They are the two contactors, the relay, and maybe one or two other little bits and pieces. So yeah, there you go. There's the latest version of the solar control system. Hope you liked the video. Thanks. Bye.